Okay. So good evening, everyone. Today we are doing our practice paper 2 for the 2027 newly started A-level batch. So in today's paper also, like the last week, we are discussing some questions from atomic structure, first few theories, and some theories from chemical calculation that we discuss some basic chemical calculation so far. And there are like containing altogether, there are 12 questions we are going to discuss, 8 from atomic structure and 4 from chemical calculations. And especially like the last day, last class, our final question was a very interesting one. You know, today also, the last question, the 12th question that we are going to discuss is something very good and something that is related to these upcoming week theories. So I'm requesting you to stay until the last one so you can have a nice idea regarding what you are going to learn in your theory classes. Okay, so then it is nice to be prepared now. So when we are discussing that in the theory class, you all can understand then the other questions also in a better way, right? So let's take today as a chance to do that one. And there are 12, like I said, 12 total MCQs, and 8 of them are from the atomic structure unit. So in atomic structure, so we have been doing our theory class for 2-3 days now, and we have discussed so far regarding the philosophical background of the atomic theory and Dalton theory and the mistakes with the Dalton theory. When we are discussing the mistakes of Dalton theory, there are 2 mistakes, and we discussed isotopes in related to that one. Okay, isotopes. Then we have discussed about the cathode ray experiments, and thereby after that we discussed about what is the model, golf ball model. Okay, then last week's you all discussed with me regarding the positive ray experiments in the class. So there are 2 MCQs from the positive rays in the today's paper. Okay, so like that, those are the questions that are there in our paper today from atomic structure. And then after that, from chemical calculation, some good past paper MCQs are there. Basically today all questions are from your past paper book. Okay, like that, these are the answers of those questions. Okay, so let's look at the first question. So it is asking about scientism, and the first one, the quantity of electronic charge was experimentally shown by. So who found the charge of electron? This one we discussed in our last theory class. So the correct answer is Millikan. So you can write some explanation. You know, we call that one as the review of the paper. Paper එකට review එකක් ලියන්න පුළුවන් ඔයගලන්ට. හරි. So when you are writing the review, please add why we are taking that answer and why others are not our answer. So can I know what Crookes did? He is the one who invented the cathode ray tube. Cathode ray tube. Invention of cathode ray tube. Okay, therefore we call this cathode ray tube as the Crookes tube also. Okay, so you can draw a small diagram just to remind what is this cathode ray tube. This is the diagram we used in our theory class. You have the cathode, negatively charged cathode, and positive anode is there. So what's happening? From cathode to anode, electrons are moving. This is what we call as the cathode ray. Okay, so this cathode ray tube was invented by Crookes. Then this one is Robert Millikan. Robert Millikan is the answer. So he found the charge of electron. You can write something more to that one. Charge of electron. Actually, the value of charge of electron is, it is important. I ask you all to remember that one. 1.602 into 10 to the power minus 19 coulomb. This is the actual charge of electron. So this was discovered by Millikan. And you can write the experiment that helped to reveal this one. It is called as the oil drop experiment. Oil drop experiment. Okay, oil drop experiment. So by oil drop experiment, Millikan found the charge of electron. Okay, lamai. By oil drop experiment, Millikan found the charge of electron. So then we can write about Rutherford, Moseley, and Faraday. So you have heard about Rutherford. So what is the atomic model that was presented by Rutherford? Can I know that too? Rutherford, what is the atomic model he presented? Okay, very good. Planetary model, planetary model, planetary model. So we are going to discuss the discussion of, we can complete the discussion of planetary model in our these upcoming classes. Okay, because last week we discussed about our positive ray experiments, and then after with the discussion of the positive ray experiments, then we have to complete the gold foil experiment. So if you take these two experiments together, we can nicely explain the planetary model. So this week mainly we will be focusing on, from the atomic structure lesson, we will be focusing on completing the planetary model theory part. Okay, right. Okay, planetary model was discovered by presented by Rutherford, and other than that, Rutherford is related with these things. Okay, so remember, we'll be discussing them in future. So he's the one who discovered proton, and he's the one who discovered alpha, beta, gamma radiations. Okay, so he discovered proton and alpha, beta, gamma radiation. So Rutherford did that too. So remember, along with the planetary model, there are two other points regarding Rutherford. Okay, so these things will be mainly, important for our MCQ paper. So therefore, with the name of the scientist, let's try to remember what they did. So then we have Moseley. In future, again, you will be learning this on Lamai. Moseley is the one who found atomic number. He proposed about the method to find atomic number. Okay, atomic number. And Michael Faraday, he did many things regarding for the development of physics and chemistry both. For chemistry, we are learning about Faraday in our unit 13, electrochemistry. So Faraday laws for electrochemistry. So you can note down like that. So each scientist that are given as answers, we know what they involved with. Second MCQ, it's asking the charge to mass ratio of the electron was experimentally determined by. Charge to mass ratio, we call that one as E over M ratio also. E over M ratio. So who discovered the E over M ratio of cathode rays? Our answer is Thomson. Okay, so these are easy questions, so we'll go a little fast. We discussed a little bit about this also in our last classes too. So Thomson is the one who discovered the E over M ratio for the cathode rays. Okay, and there are some other scientists mentioned, Crookes and Millikan, we already wrote about them. Then you can write about Geiger and Marsden. And then we have Chadwick. So these names of scientists are somewhat important because they are asked for the MCQs. Like that, some MCQs will be there in your papers. Okay, you don't need to know many things, lot of details about them. Just the name and how they contributed for the development of atomic theory, that is enough. Okay, so yeah, the charge to mass ratio, E over M ratio, was discovered by Thomson. For electrons, it was discovered by Thomson. Okay, J.J. Thomson. And we will complete about the scientist, the information. Geiger and Marsden are the two other scientists involved with Rutherford to do the gold foil experiment. James Chadwick. In our last paper class, we saw his name, as I remember. Yes. What is the discovery that was done by Chadwick? We haven't discussed that one yet, but still, yeah, okay, very good. Neutron. So neutron was discovered by James Chadwick. Okay, so like that, just then complete the theory part. So once you learn about the gold foil experiment, you can add more information to this one. So like that, when we are reviewing the MCQs regarding scientism, we can write what is the relevant scientist and what other scientists did for the development of chemistry. Okay, so like that we can give some explanation. That is what we are calling as writing reviews. Before that, I want to discuss with you, Lamai, small bit regarding the charge to mass ratio. Charge to mass ratio. So there are some MCQ points connected with that, no? So they are very important to remember. So I'm going to revise them again so you can write them in your paper class book. Okay. So the important thing is charge to mass ratio for cathode rays. For cathode rays, E over M ratio is same, or you can say E over M ratio is independent of the type of gas and type of cathode. Okay, so let's write type of gas. So whatever the gas you are including to the cathode ray tube, okay, always your cathode E over M ratio of the cathode rays will be same, because the thing is, Lamai, because always cathode rays are electrons. So no matter what gas you insert, no matter what the metal you use to prepare the cathode, right, it is always the cathode rays that are traveling from cathode to anode, they are always electrons. Okay, so electrons is always the same thing. Understand? There are no different types of electrons. You have the same electron. Okay, so that's why cathode rays are having their EOM ratio is independent of the type of the gas. Okay, so we are basically, what is EOM ratio? Charge of electron and mass of electron. Since these are constant, EOM ratio is also constant. Understand? So cathode rays are what? Always electrons, and all electrons are identical. All electrons are identical. All electrons are identical, right? And the next one we can write about EOM ratio of the positive rays that we learned. Okay, so for positive rays, okay, what are the other names for positive rays? We can call positive rays as canal rays, and there is one more name. We can, yes, very good, anode rays. Okay, for positive rays, for canal rays, for anode rays, the E over M ratio depends on the type of the gas you insert. Okay, so for positive rays, E over M ratio is depending on the type of gas inserted. Why? What is the reason for that one? Type of gas. The reason is, so positive rays, it depends on the gas, right? Let's say if you included hydrogen gas, the positive ray particle will be H plus. Okay, then for any other gas, let's say for nitrogen gas, it will be N plus or maybe N2 plus, whatever, right? So the positive particle, let's say it is N plus, right? The positive particle depends on the gas we insert. Therefore, their charge and their mass, the ratio is also depending on the type of gas we have chosen. Okay, for the hydrogen mass and nitrogen mass, the particle masses are also different, and charges of them may be also different. You get what I'm telling, right? So therefore, the charge to mass ratio will be obviously different for different types of positive rays. Okay, so therefore, just remember that as a point, Lamai. And we can add something more. We can say this point also. So who get the highest E over M ratio? Highest E over M ratio for the positive rays, is given by hydrogen gas. Okay, hydrogen gas. H2 gas gives the highest EOM ratio, which is actually H plus. Okay, H plus. And then all other gases, they are having the whole number divisions of their whole number divisions of this value. So we write a clean note regarding this one. You already have that one in your theory book. Just please refer this one with that. Okay, I hope you remember that one. We wrote about electron EOM ratio, hydrogen EOM ratio, and nitrogen EOM ratio in that example. So you can look at that one again and just remind this fact there. So actually the largest EOM ratio, when you compare the cathode and anode rays, it is always the cathode rays having the highest EOM ratio. Okay, so this one is the highest value. So this is bigger than 1840 times than the hydrogen's EOM ratio value. Okay, just remember this theory point. I'm just reminding you because they are so much important when it comes to questions. Okay, so is there any problem with this one? Right, let's go to the third one. It is about isotopes. So there are like 2 questions here regarding isotopes. So let's quickly review them also. So it's a ABCD type question. So that means there may be several answers. Right? Isotopes of a given element. So isotopes are the definition. Okay, so let's write the definition of isotopes. So it will be enough for the review. So this is the definition. So this is kind of a definition I made to remember. Because when you say the same element, it is obviously telling you the atomic number is same, but still we are writing them as 2 points just to make sure that we don't miss anything in questions. Okay, right. So according to this definition, you all can see the reason for the existence of isotopes is having different number of neutrons. Okay, having different number of neutrons. So what is the example we took in our theory class? We took the 3 isotopes of hydrogen: protium, deuterium, and tritium. Okay, so you can see here the number of protons are the same because they are the same element, no? And the number of electrons will also be the same. Okay, isotopes are having the same electronic configuration. Remember, because of their same electronic configuration, they have the same chemical reactivity, isn't it? But because of their mass is changing, you can see the mass number is changing here, right? Then they will be having different physical properties. And if you take the neutrons, you will see here something very interesting. The protium isotope is not having any neutrons, right? You can see neutrons from deuterium and tritium. Okay, so that is another MCQ point. Remember, okay, so we wrote that some and not all elements are having neutrons. Okay, except the protium isotope of hydrogen, all other atoms and all other elements are having neutrons. Okay, so that one is another MCQ point. I'll write that too. Except protium isotope of hydrogen, all other atoms of elements are having neutrons. Okay, so protium doesn't have any neutron. That's another MCQ point. Okay, so what is the answer for this question then? It is asking you what are the correct statements. So there are 4 statements. So you can see the A is wrong. So they don't have the same number of neutrons. Isotopes are having different number of neutrons. So A is wrong. Then you can see B, they have the same number of protons. That is true. And electrons also, there are same number. So C is also true. Okay. So without any doubt, you can say A is wrong and B and C are correct. But what about D? D is something new, right? What is that name? Nucleons. See, nucleons. So you have to add a special review. Okay, a special review to explain nucleons. Okay, nucleons. So what are these nucleons? Some of you might have already searched the internet just to learn, just to see what are nucleons. Okay, that's very good actually. Okay, that's what is called as learning. Right? ඉගෙන ගන්නවා කියන්නේ ඒකට. Right? ඉන්ටර්නෙට් එකේම search කරලා ගොඩක් වා බලන්න. අලුතෙන් ඒවා හම්බුණා. Right? මොකද්ද මේ nucleons කියන්නේ? Okay, so nucleons, it is a separate topic lamma actually. Nucleons. If I just give you a small idea, nucleons are the different types of nuclei. Nucleon number is same as the mass number. Okay, it is representing number of protons and neutrons. Okay, so you can see in isotopes nucleon number is different. Right, shall we go to the fourth one real quickly? So it is asking which one of the following statement concerning beam of electrons is true. Beam of electrons is true. So what can you give me another name for the beam of electrons, Lama? Beam of electrons. Give me another name for the beam of electron. We learned that one. A beam of electron you can call as what? Yes, very good. Cathode rays 2. Okay, cathode rays 2. So let's write down that beam of electron, in front of that write cathode rays. Okay, so you can call it as cathode rays also. So they are asking statements regarding cathode rays. So if you just recall some familiar name to you, right, it will be really easy when you discuss the question and you understand the question. ඔයාලට රංගාලා මොනවා හරි මේ වගේ අර ළඟ නමක් ක්ලික් වුණොත් එහෙම beam of electron කියන්නේ cathode rays වලට කියලා ක්ලික් වුණොත් එහෙම ඔයාට මේක අර තේරුම් ගද්දි හරි ලේසි. ඒකයි. හරිද? right, දැන් බලමු ගිහින්. So beam of electrons ගැන they are asking the correct statement. So you can see lamai none of them are true, no? Isn't it? මේ හැම එකක්ම වැරදි. So the answer for the fourth question we took as the answer 5. So we have to write, it's very important, right? We have to write why those other 4 statements are wrong. හරිද? අපි ලියන්න ඕනේ මේ අනිත් statements අතර ඇයි වැරදි කියලා. Right? Okay, now tell me what is the mistake with the first statement? It is attracted towards the cathode. So what do you think? What do you think? Will they be attracted towards the cathode? So what is actually cathode here? Okay, so I can see some answers. Okay, but before everything, before that all, just look at this diagram. So if you want to generate a beam of electrons, or you can say a cathode ray, right, you are using this setup now. So the beam of electron is this, right? So if you placed an electrical field here, let's say negative and positive here, understand? So these negative positive electrodes are also called as cathode and anode. Okay, so it is true that they are originating from cathode, okay, and they are traveling towards anode because they are attracted towards the anode. Okay, but if you put another electrical field, that also you can name as cathode and anode now, right? And this is your cathode and this is your anode of the other electrical field. Now think about these cathode and these anode and answer that one, Lama. Then it will be more clear. Still you can get the answer, no issue, but you can give a clear answer, clear idea if you consider the external cathode and anode. You get what I am telling? Huh? If you consider external cathode and anode, then you can give a nice explanation. Okay, that's what this question is asking. Is that clear? Okay, then what can you tell? These beam of electrons, they are actually negatively charged, no? So then they would be attracted towards the positive electrical field, or you can say they will be attracted towards the external anode. External anode. Okay, and they will be deflecting away from external cathode. Is that clear now? Okay, then we can write a nice explanation. Okay, so why the first statement again false? Let's go and see quickly. It is attracted towards the cathode is wrong. It is deflecting away from the external cathode. Okay, and then the fourth statement is also wrong. It is telling deflecting away from the anode. No, it is deflecting towards the external anode. Okay, so anyway, that two statements are wrong. If you consider external cathode and anode, you can explain it nicely. But if you just ignore the external cathode and anode, if you just stick to the same cathode and anode, still you can explain this. Okay, so no issue. But when you are writing the review, හරි ඔයා review එක ලියනකොට external එක දාලා ලියන්න. ඒක තමයි හොඳට තේරෙන්නේ. Okay, නැත්නම් පස්සේ දවසක ආයෙ බලද්දි ළමයි clear නැති. Okay, right, so let's go to the second and third statements. They are telling you about the magnetic field and electrical field. So what do you think about that one? It is attracted towards the north magnetic pole. It is attracted towards the south magnetic pole. So is that correct? The north south පැත්තට attract වෙනවද? මොකක්ද ඒකට අපි ලියන්න ඕනේ? What should we write in short? Just type it and send us. So what should we write? Is it attracting towards the north pole or the south pole? So what happens there actually? So some of you are sending the answer. So all the answers are correct. Okay, very good. So these cathode rays or beam of electrons here, they will not attract towards the north or south pole. Okay, so they will be deflecting perpendicular to the field. Okay, so they will not attract towards the north pole or south pole. Okay, that's a very common MCQ point they're asking. So we have to decide that it is wrong. Okay, so if you place a magnetic field, what will happen? They will not go towards the magnetic field. Okay, so what will happen? It will deflect perpendicular to the magnetic field. So let's say here's our cathode, negative, positive, and cathode rays are coming in this way. So you are placing a magnetic field here. So let's say this is your north pole, and behind the board you have the south pole. Okay, so your magnetic field lines are into the board. Okay, so when electrons are moving in this direction, since they are negatively charged, current will be flowing in the other direction. Then what you are doing, you apply Fleming's left hand rule. So this is my left hand, right? The thumb is representing what? We wrote these things in our theory note. Okay, the thumb representing the force, and index finger representing the direction of the current, direction of the magnetic field, and your middle finger is representing the direction of the current. Okay, so if you apply that one here, so index finger to the board and direction of the current should be to other side. So I have to turn my hand like this, and where my thumb is pointed, it is pointed directly downward. Understand? So the cathode rays will not go towards the north or south pole. Okay, so cathode rays will come and they will bend along the board to the perpendicularly downward. Understand? So my north pole is in front of the board right here. My south pole is behind the board, but cathode rays will not go any direction. So cathode will not come in front of the board or behind the board. Okay, so cathode rays will go along the board and deflect downward. Okay, that is what meant by perpendicular deflection. Okay, so what should we write? What should we memorize? So you can say cathode rays in you can say start by telling in magnetic field. In magnetic field, cathode rays deflects perpendicular to the field, where other positive particles deflect. where the positive particles deflect. Okay, so sorry, not positive, negative. Cathode rays are negatively charged now, where the negative charge particles deflect. So all the negative particles are deflecting downward if you place the north and south poles like this. Okay, is that clear, Lama? Then what happens? Right, so they do not deflecting towards north or south pole. You can add that too. Do not deflect towards north or south pole. Fifth one here, actually this theory point I asked several times in the our class. So what's the answer? Which of the following get deflected when moving across the magnetic field? Now we just discussed a question regarding the magnetic field. Now with this one you can answer, Lama. So what do you think? In a magnetic field, yeah, B and C are the answers. In magnetic field or electrical field, what is our theory point? Can you type that and send? It may take a few seconds, but still it is worth. Okay, so what is the theory point we remember regarding this? By now you should remember that one. For the fifth MCQ, what's the theory point? If you summarize the question, the whole question into one point, what you should write in your review? Just think and tell me, Lama. මොකද ළමයි ලියන්න ඕන theory point එක අපි ඔකට එකක් ලිව්වා එදා ක්ලාස් එකේදී මතකද බලන්න පුතාලා වගේ කට්ටිය කියනවා මෙහෙම cathode rays are negatively charged කියන එක ඒක නෙමෙයි cathode rays are negatively charged කියන එකම නෙමෙයි yeah some few of you are telling the correct answer what I needed. Yeah, okay, good, very good. Oshini Disana Tesandu Misra oh then හැමෝම දානවා okay, very good, හොඳයි. Okay, the thing is this one, any charged particle deflects in electrical or magnetic field, electrical and magnetic fields. Okay, so that's the correct answer. Okay, so you can summarize the whole thing into one point. Okay, so only charged particles, you can say only charged particles deflects in electrical and magnetic fields. Electrical and magnetic field. So here our beam of electrons, they are electrons. So it's a charged particle. So it must deflect. If you get anode rays, the positive rays we discussed in the last theory class, that is also a charged particle. It's a nuclear. So then it will also be deflecting. Understand? So like that, any charged particle will deflect in electrical and magnetic field. Okay, so any charged particle. So let's go to the answers and check whether what are the charged particles and what are the uncharged, or we can say neutral particles. So you can say neutron is a neutral particle. There is no charge for that one. That's why it is not deflecting. But cathode rays, you can say negatively charged. Okay, so the review you can write that one. Okay, cathode rays negatively charged. Then proton positively charged. Okay, so they both will be deflecting, but deflecting to opposite directions, isn't it? That is also a nice thing. Okay, I'll write it somewhere. So neutrons, it is neutral, and then you can say cathode rays negatively charged, and protons, those are positively charged. And finally you have helium atom. So atom itself, any atom, okay, it may be a different element, it may not be helium, right? Any atom always neutral. always neutral. Any atom, basically any atom is a neutral one. Okay, so therefore they will not be deflecting. Why atoms are neutral? Because the number of protons and number of electrons are equal. That's why they are neutral. Number of protons and it is equal to number of electrons. Proton gana electron gana lamai equal. ඒ හින්දා මෙයා electrically neutral. Charges balance වෙලා තියෙන්නේ. දැන් ඔයා ගන්න helium. Helium has 2 protons and 2 electrons. So overall charge is 0. Understand? Helium atom. Therefore, it is again neutral. So those two particles will not deflect, but cathode rays and positive protons will deflect. And remember, they deflect to the opposite direction. Because of the positive negative thing, you can say deflects to opposite direction. So very basic theory lama, yeah? Opposite direction. So just understand it. You will never forget this one. Okay. Right. Okay, very good. So you are actively participating in the class. That I really appreciate. Very good. Okay. Shall we go to the next point? So is there any doubt here in the 5th MCQ? Anything to add more? The 6th question is again from isotopes. That carbon monoxide theory point, and I discussed in each of your theory classes last week. So I just added that original MCQ. This is the MCQ I talk about the theory class lamai. මම ඔයගොල්ලන්ට theory class එකේ කිව්වා නේද මේකෙන් MCQ එකක් අහලා තියෙනවා කියලා. carbon monoxide කතන්දරේ. ඕක තමයි ඔය MCQ එක. Okay. So let's discuss that one now. See the 6th one. I'm going to erase the board. Okay. Carbon monoxide sample is there. So it's the same thing that we had the theory class lamai. This telling only C614 and CO616 isotopes for one carbon monoxide sample, and the other carbon monoxide sample you have C612 and C6 O8 oxygen 18. Yeah, there's a small mistake. It is telling C818. It should be O818. Okay. Right. So there are 2 samples of carbon monoxide. 2 samples of carbon monoxide. One is having carbon C614 and oxygen O16. And here the other carbon monoxide sample is having carbon 12 and oxygen 18. So according to the theory discussion that we had in our theory class, okay, you all remember lamai, this carbon monoxide, if you take the molecular mass, that molecular mass is the same, isn't it? So how do we find the relative molecular mass? Relative molecular masses are equal to the sum of mass numbers, right? Sum of mass numbers. So if you take the mass numbers, here carbon 14, 16. So mass number is 30. Okay, and here the mass number is what? Again 30. So their sum of the mass numbers are 30. Understood? So the masses of these carbon monoxide molecules are the same. Basically, the masses of the 2 samples are the same. Okay. So therefore, masses of 2 samples are the same. Because of this isotope mix. Okay. So isotopes are having by in theory we just say isotopes are having different physical properties. Okay, so density and masses, those are physical properties, but still here, okay, because of the matching of the different isotopes in order to become the total 30, okay, because of that matching thing, the masses, the densities, they all have become similar. Okay, they all have become similar. So in your question, if you go lamai, can easily understand. Hari? Baranako? The chemical reactivity anyway, it is similar because isotopes are having similar chemical properties and their molar masses are all similar. Molar volume will be similar and densities will be similar, right? Only thing that is going to be different is the percentage of carbon and oxygen by mass. Okay, percentage of carbon and oxygen by mass. So I'm going to show you how to find the carbon and oxygen percentages. So let's find, we will only check the carbon percentage. Let's take this sample. What is the carbon percentage? Okay, so here having C614 isotopes and the total mass is 30. It's 14 by 30 into 100%. Here the carbon percentage in this sample, you are having 12 carbon atoms and the total is 30 into 100%. Now you can see their carbon percentages will be different. That is the only significantly different thing. Okay, so their densities and everything is going to be similar. Okay, so masses are same. Therefore, density, molar masses will be same. Chemical reactivity is anyway same because they are having the same configuration, because they are the same compound. Okay, so what's going to be different is the carbon percentage and oxygen percentage. So I didn't write anything for oxygen percentage. When you are writing the review, you can add that oxygen percentage thing also. So that like that, answer for the sixth question is the property that with the significant difference is the mass percentages of each element. Okay, all other things will be same. So that's a very good MCQ, Lamaya. You can put a star to that MCQ. Okay, and the fifth MCQ is also equally very good because they're asking whether they are deflecting or not. That is also a good point. Okay, so then we are having two MCQs from positive rays. MCQ 7 and 8. We'll discuss them together. And this positive ray is the experiment, is the theory part we completed in our last week theory class. Okay, shall we go to the question first? So look at the first statement of the seventh question. Positive rays are formed when an electron is removed from an atom or molecule in a cathode ray tube. Okay, so that's how actually positive rays are created, isn't it, Laman? So what's the difference here? Okay, so can anyone tell me what is the significant word here in the positive ray experiment? When you compare that with the cathode ray experiments, positive ray experiment has something very interesting. One word is there. And right, very good. Perforated cathode, isn't it? Perforated cathode. You are having a perforated cathode here, not like the complete cathode you had in cathode ray experiments. Here you are having a perforated cathode. Okay, perforated cathode. So like this. So what is happening? The usual cathode rays are going from cathode to anode without any problem, without any issue. Cathode rays are going. But because of the high voltage you apply, this is the story, Lama, actually, behind the cathode ray anode ray formation. Due to the high voltage you apply here, you are applying around 5 to 15 kilovolts. It's a very high voltage. Because of this high voltage, okay, because of the high voltage, there are some already existing positive particles. Those positive particles are accelerated. Okay, so in any gas containing tube, let's say here you are having hydrogen gas. Okay, any gas containing tube, you are having a small number of positive ions. Okay, so these ions are accelerated. Ions are accelerated because of this high voltage. So these accelerated ions can knock out electrons from atoms and molecules during collisions. Okay, molecules during collisions. This is the explanation, right? Just remember this one. Remember the story. Let's say you are having hydrogen gas. First it is gone to 2 hydrogen. It is broken into 2 atoms. It is broken into 2 atoms. And then from atom even, there is a nucleus and the electron is moving now. So by further collision, H also will be ionized to H plus. Okay, and nucleus and electron separated. So like that, electrons will be removed from atoms. Okay, so this is what I said here. So basically that's how the positive rays are created. So within the medium, these positive rays are generated and they will come towards your cathode. But if the cathode is having some perforations, they will pass through the perforations away from the cathode. Okay, so these are that's why they are called canal rays, because they are passing through the holes, and we call that the anode rays and positive rays, like that here. And one of you had said another very important term we discussed here, the color of these things. They are having a faint red glow. Faint red glow. Okay, right. So in our theory class, we explained this thing together with the cathode rays. Okay, so then it will be much more refreshing and much more helpful to remember. So here I'm just revising you the diagram we added. Okay, so I'm not going to do the whole theory. There's no time to do such things now. Just I'm revising you here. Okay, right. So what about the first statement? Then it is correct, no? It is correct. And what about B? Cathode rays are originated from cathode. That's actually true, because here you can see this diagram. You know, from your power supply, electrons are coming. Electrons are coming, and these electrons are sort of jumping from the cathode to anode. Okay, so if you say cathode rays are originated from cathode, that is 100% correct. But the next statement is wrong, Lama. Okay, cathode rays originate from cathode. Originate from cathode. But your anode rays are not originating from anode. Anode rays, they are not originating from anode. Okay, so you can understand, according to this mechanism, they are originated. So they don't come from anode. Okay, so nothing jumping out from anode. Okay, just like the cathode D from cathode. Okay, so anode rays are not originated from anode. Not originated from anode. So remember that as a fact. Okay, it's very important. So we discussed this one, and we wrote the same theory point in our theory book also. So let's add this one again to our theory, our paper review also. You can say then why these are called as anode rays? Why these are called as anode rays then? You can write that one to your paper review, looking at your theory book. Why? Because they are coming from the direction of the anode. So they are not originating from anode, but they are coming from the direction of the anode. Anode is right here, no? So they are coming from that direction. That's why they are called as the anode rays. Okay, Lama? Clear, no? Yeah, they are positively charged. That's true. Anode rays are positively charged. That's why they are attracted towards the cathode at the first place. Because of the holes of the cathode, they pass through those holes. Because of their positively charged, we call them as positive rays. Understood, Lama? We call them as anode rays because they are coming from the direction of the anode. Okay, not because they originate from anode. They don't originate from anode. Then you can see, Lama, A, B are true. C is wrong because positive rays are not originating from anode. That's very important point. And D statement, Cathode rays are a type of electromagnetic radiation. What do you think about that? Why that is wrong? So then what are electromagnetic radiations? So electromagnetic radiations is a topic that you are having in your next atomic structure tute. Okay, that will be the first topic we are discussing in that tute. So until that, just tell me, what do you know about electromagnetic waves in your level class? Electromagnetic waves are a type of energy. Waves basically a form of energy transformation, isn't it? Electromagnetic waves are, you know, what are the examples to electromagnetic waves? Light rays. Yeah, they are transers. Okay, very good. Okay, electromagnetic waves are, these are the electromagnetic waves you need to remember. So for your explanation, just write them. You have radio waves, then you have microwaves, then infrared waves, visible, then you have UV, then you have X-rays, and then you have gamma rays. Gamma rays. Gamma, this is the symbol. Okay. So why did I say this greater than sign? Because towards this direction, what happens? Frequency and energy increases. Frequency and energy increases. The wavelength symbol is lambda. Wavelength decreases in that direction. Okay. So what about the speed of the electromagnetic waves, Lama? What do you know about the speed of electromagnetic waves? Just add it to the chat. That point also important. What do you know about the speed of electromagnetic waves? What do you think? 3.0. Yeah, they are very fast. Actually, electromagnetic waves are the fastest thing in the universe. Light speeds, remember light speeds? 3 into 10 to the power 8 meters per second. 3 into 10 to the power 8 meters per second. Okay. 3 into 10 to the power 8 meters per second. That speed, they are in a vacuum. Okay. In a vacuum. 3 into 10 to the power 8 meters per second in vacuum. Speed of light. That point is also very important for us. It is known as C. Okay. Remember the C equal. Yeah, I'm gonna stop right there because anyway, next time we will be discussing that now, right? Otherwise, it will be too much information and maybe you might get confused also, right? Okay. Then, do you see here cathode rays? No, right? These are the electromagnetic waves, so no cathode rays. Because of that, cathode rays are not electromagnetic waves, even though they are called as rays. Don't get confused with electromagnetic waves. Okay. So, like I said, there is a separate chapter for the electromagnetic waves. We will be discussing more about that, and we will be doing calculations from that too. So then we can obviously study that later. Okay. So therefore, we're gonna stop right there. Cathode rays are not electromagnetic radiations. Okay. Right. So that's about the 7th question. So you can understand now why C and D are wrong. Again, if you go to the 8th question, there is telling about statements are there. Let's see that too. Which of the following statements are true regarding the positive rays which have been detected during the experiments with discharge tubes in determining atomic structure? So A statement, they are found together with the cathode rays and responsible for the glow observed in the region behind the perforated cathode. Okay, so that one is very true. So you can write the color of the glowing. So what is the color I earlier told you, and one of you also told that in our chat? What is the color of that glow? Islama, what is the color? Its color is faint red glow. Okay, faint red glow. So let's write that color. Okay, so until you get the printed paper, you can write them in your book. Okay, so you can say 8A, true. You can say faint red glow. And what about B? B. Okay, very good. You have given the answers. In B, they are formed by loss of electrons from atoms or molecules. That is true. That is true. We discussed already about the generation of positive rays. So you can write a review regarding, the short, you can write a small summary regarding the formation, the mechanism of formation of positive rays or anode rays. We can write down that here. Okay. Then C, they consist of particles whose mass is independent of the residual gas. So that is wrong. So their mass is depending on the residual gas. Okay, Lamai, their mass is depending on the residual gas. You can say mass depends on the gas. Okay, so if you take like hydrogen, then for hydrogen gas it is H plus. For nitrogen gas it is, let's say, N plus. So the mass is relative atomic mass is 1. Here relative atomic mass is 14. Remember? So it depends on the gas. So telling it is independent is wrong. Okay, telling it is independent is wrong. Just give an example like that. Okay, so sometimes other than writing lengthy answers, it's good to say the same thing with an example. That's what I'm doing mainly during the teaching also, no? So what about the last statement? They are not affected by electrical and magnetic field. Telling that they are not affected by is wrong. Okay, so anode rays are charged. Anode rays have a charge. So therefore any charged particle have a positive charge. You can say positive charge. If you be more precise, you can say anode rays are having a positive charge. Therefore they are affected by electrical and magnetic fields. Okay, so therefore they are affected by electrical and magnetic fields. Understood that? Therefore they are affected by electrical and magnetic fields. Okay, so it's a short sort of reminding regarding the same theory we did. Okay, so that is actually the aim of our paper class, right? So 9, 10, 11, 12, there are 4 small chemical calculations. We'll do that also quickly. Details regarding the question. It is asking the number of moles of sodium plus. That is the question, the 9th question. That's what they're asking. Moles of sodium plus. The data given, you have sodium thiosulfate. That's the name of that compound with 5H2O. And you have how many grams? 1.24 grams. It's a good question to revise few things, Lama. Okay, first of all, so this compound, the name of this compound, Na2H2O3, it's a very very common compound in our syllabus, Lamai. The name of this compound is sodium thiosulfate. Sodium thiosulfate. Okay, so this is thiosulfate. Okay, so this compound is hydrated sodium thiosulfate. We have water along with that. So like that, remember in our last week discussion, we discussed few things about this. When you take the molar mass, okay, molar mass, calculate the molar mass of this compound, you have to count the water also to that one when you take the capital N. Okay, so let's try to do that one. The molar mass of this compound is equal to sodium. You have 2 sodium atoms, so 23 into 2. Then you have 2 sulfur atoms, 32 into 2. These values are given. Sodium, sulfur, the values are given. And oxygen, you have 3 of them, 16 into 3. And then one water molecule is 18 grams per mole. So you have 5 of them. So 18 into 5. Okay. Then you can see 23 into 2, 46. Okay, 64. And 16 into 3 also 48. And 18 into 5, 90. So if you add them up, it's 18, 1, 10, 11, 15, and 24. 248. 248 grams per mole. 248 grams per mole. Then you can find now from the whole compound they have given this mass. So what is the formula you have to take here to find the moles? Moles is equal to, this is one of the 5 formula we learned to find the moles. Mass over molar mass. Okay, so the mass given here is 1.24 grams. Please apply with units, Lamaya. 248 grams per mole. Okay, so for those who need the simplification support, here's what you can write. You can write this 1.24 as 124 into 10 to the power minus 2. Isn't it? From scientific notation, you can do this one. And then divide this one from 248 here. So then you can see, you can cut this and with a pencil you have to cut. Here, then 0.5 into 10 to the power minus 2. Okay, so the answer is going to be 5 into 10 to the power minus 3 moles. Okay, because this one, you know, when you take the decimal point to the right side, 10 to the power minus value increases. Okay, just remind your O-level theories. Okay, I think this stuff is not that difficult. So then anyway, this is the number of moles of this compound. So what the question is asking, number of moles of sodium. Number of moles of sodium. So there we have to write a very important statement. Okay, very important statement. So look at the formula of the compound, Na2H2O3 and 5 water. 5 water. So if you take a mole of compound, let's say you take 1 mole of this compound, you have sodium, how many moles? 2 moles, isn't it? You have sodium 2 moles. There are sodium 2 moles. So how many moles of sulfur? You have sulfur again 2 moles. Okay, you have oxygen 3 moles. Okay, you have hydrogen, how many moles? 10 moles. Just 5 into 2. You have oxygen again 5 moles. This number responsible for all the numbers that are following that. Okay, so like that, these are the moles of each element: sodium and sulfur and oxygen. Here you have to add these 2 oxygen also. This is also oxygen. You take both the oxygen, you will have like 15 moles. 15 moles of oxygen. And this is hydrogen. Understood? So like that you can explain the number of moles of each compound, Laman. Okay, here you can't see. I wrote here oxygen. Okay. So like that, if you are having 1 mole of compound, here you will have 2 moles of sodium. Now we found the actual number of moles of this compound. Therefore, we can say, since compound to sodium ratio, compound to sodium plus ratio is 1:2, because in each compound you have 2 moles of sodium pluses. Okay, try to understand that. We can say moles of sodium, we are writing subscript as sodium, is 2 times the number of moles of the compound, right? That means how many moles? 10 into 10 to the power minus 3. That means 1 into 10 to the power minus 2. That's our answer in moles. In answers, they haven't given the units because they are asking how many moles are there. You just say 10 to the power minus 2. That is enough. Okay, so anybody have a question about this one? Is this clear to you? So answer will be what? Answer 4. 9th one, answer 4. Right, it's a good question, huh? So basically any chemical calculation is a good question. හරිද? ඕනම එකක් හොඳ ප්‍රශ්නයක් තමයි. මොකද මම ඒකයි පුතේ මේක මුල් කාලෙම පටන් ගත්තේ. මම දන්නවා මේක පොඩි තියෙනවා ඔයාලගේ පොඩි මුල් රෙසිස්ටන්ස් එකක් මේ පාඩමට. හැබැයි මේක කරන්න ඕන. හරිද? අර අපි කියනවනේ නේද? අර අමාරුයි කිය ඔක පිටිපස්සට මේ කල් දදා හිටියොත් එහෙම මොක හරියන්නේ නැහැ. ඔය වෙලේ හරිය අපිටමයි ඩැමේජ් එක වෙන්නේ. ඒ වුණාද? අපි හැම වෙලෙම හිතන්න ඕනේ අපි හොඳම රිසල්ට් එකකට යන්නේ කොහොමද A levels වල කියලා. Right? Now you are having like 2.5 years. So we should always think how to get our best during that time. Okay? That's why we started this calculation thing from the very beginning. Normally people don't do this one. හරි ඔයාලා check කරලා බලන්න classes වල සාමාන්‍යයෙන් මෙහෙම කරන්නේ නැහැ. මොකද chemical calculation එකක් කරන ඒ lesson එක පටන් ගන්න එක පුතේ class එකක් අපි නිකන් හිතුවොත් එහෙම මේක නිකන් business එකක් පැත්තෙන් හිතුවොත් ඒක very bad decision එකක්. හරිද? මේ පාඩම පටන් ගන්න එක. හැබැයි මම මේක ඔයාලට කරන්නේ ඕගොල්ලෝ වෙනුවෙන්. ඒත් ඔයාලා මේක කරොත් අපේ මම දැකලා තියෙන experience එකකින් හරි අපේ classes වල මගේ පරණ batch හැම එකකම ළමයි මාරම දක්ෂයි calculations වලට. හරි? ගොඩක් අය හරියට ගණන් හදනවා. මම කියන්නේ හැමෝම මේ මහා හරියට ඔක්කොම හදනවා කියලා. එතනත් ඉන්නවා සමහර ළමයින්ට මේක තාම struggle කරන but එයාලා හිතියට වඩා හැමදාම improve වෙනවා. පොඩ හරි improve වෙනවා. right? ඒ ඉන්න මේක අතාරින්න එපා. මේ ගණන් study කරන්න. දැන් ඕගොල්ලෝ ළඟ ගිය week එකේ මම online කරපු questions 4ක් තියෙනවා. අදත් තව 4ක් තියෙනවා. මේ 4 හොඳට study කරන්න ඕනේ. Okay? So you have to keep repeating the studying this, okay? So you have 4 questions from our last week class and you have another 4 from today's class. Okay, so note them down properly and study them. Okay, and keep repeating them. Okay, you don't have to do 1000 questions to get the chemical calculations better. What you have to do the 50 questions you have. Let's say you have 50 questions. You have to keep repeating those 50 questions. Then you will be okay with the lesson. Okay, so that's what we have to continue and doing. So all my previous batch students they are very good at this one. Okay, not because of the what I teach, okay, because we started this one practicing from early. That's why we are so good at this one. So they were also just like this lamai hari because at the very beginning they were struggling even with simplifications, but now they are very good. Yeah, let's focus on the question, right? 10th one. So what it is asking? Yeah, it is telling chromium 3 plus ions in this compound. It is telling chromium 3 plus ions are 1.04 grams per decimeter cube. Okay, so what is the sulfate concentration in moles per decimeter cube? They are asking sulfate concentration in moles per decimeter cube. That's the question. Moles per decimeter cube. Okay, let's see how to get the answer quickly. And the molar masses are given: chromium, potassium 39 and chromium 52, sulfur 32, oxygen 16, hydrogen 1. These values are given. Okay, right. So what is this unit means to us? What is unit means? What? 1.04 gram. Okay, now when you see, this is also a good question, Lamai. Huh? You have to get the meaning of this value. What is the meaning of this one? Meaning. What this means? Okay, telling you in 1 decimeter cube of the solution. Okay, in 1 decimeter cube of the solution, there are 1.04 grams of chromium 3 plus ions. Okay, there are 1.04 grams of chromium 3 plus ions. That is the meaning of this value. It is not the density, okay? So it is having the units of density, grams per decimeter cube, something like that. But don't misunderstand it as the density, okay? What it is telling is, in this 1 decimeter cube of solution, there are 1.04 grams of chromium. It's very easy, isn't it? Right. Now, what we can find is, you know the mass of chromium 3 plus ions. So from this, you can get moles of chromium 3 plus ions. Let's find moles of chromium 3 plus ions. So what we have to do, we have to divide the mass by its molar mass. Mass is given 1.04 grams. What is the molar mass? What is the molar mass? So what they have given is the chromium equal 52 is the 52 will be the molar mass of chromium itself. Okay, so chromium, M chromium is 52. So what about M? Can you all see this one? M chromium 3 plus. What is the value of M chromium 3 plus? What do you think, Lama? What is the value of M chromium 3 plus? Can I have your answers here, please? That's a very important thing we are discussing here, okay? Yeah, so I'm seeing some answers, right? So here's the thing. Its value is same as 52. Why? Because when you are getting chromium 3 plus, you are removing 3 electrons now, isn't it? So this electron is having, electron mass is negligible. So we are ignoring the mass of electron. That's why we get the 52 here. Is that clear to you all now? So therefore, we divide this one by 52 grams per mole. That's the molar mass of chromium 3 plus. Okay, so if you mistaken this one, please write it properly. It's a very important point. Okay, chromium molar mass is same as the chromium 3 plus molar mass. Okay, Laman? I hope you all got it, right? So I can see some different answers also. Some of you are given. Okay, but make sure you understand this one. If there is a doubt, you can always ask in the class even. Anyway, we'll be doing more questions, don't worry. So what is the number of moles here? 1.04 divided by 52. Okay, you can say like this, no? 104 into 10 to the power minus 2 division 52. 2 times 2 into 10 to the power minus 2. 0.02. 0.02 moles of chromium 3 plus is there. Okay, chromium 3 plus is there. Now, if you consider the compound, okay, let's say in 1 mole of compound, you have how many moles of chromium? Chromium, you have chromium 3 plus is there. Chromium, you have, Lamai, 2 moles, isn't it? 2. Sulfate, how many you have? Here you have 1, here you have 3. Here you have 1, here you have 3. See? So then you have sulfate 4 moles. In 1 mole of compound, you have chromium 2 moles and sulfate 4 moles. Is that clear to you all? This is the similar application like we did earlier. Is there any problem with this one? So now you can see chromium to sulfate, you know, the ratio 2:4. So you have always 2 times bigger, right? 2 times bigger. Then you can get the moles of sulfate in 1 decimeter cube. Okay. So if chromium is 0.02, okay, let's say chromium is, actually you are having this value now. So then what should be the sulfate value? Should be 0.04. That is 0.02 moles moles, and this one will be 0.04. Okay, moles in 1 decimeter cube, isn't it? So this will be the concentration of sulfate. Okay, 0.04 moles per decimeter cube. 0.04 moles per decimeter cube. This is a good question. Somewhat maybe a difficult one. Okay, so if you can understand this one, you are very good. Okay, but still, if you don't get it, just look at this one more time. You may understand that one, right? You can always check the recording too. So, are there any doubts in this one? In the way I explained. So there are other answers also. Other ways of getting the same answer. මේක ගන්න වෙන ක්‍රමත් ඔයාලට හදා ගන්න පුළුවන්. But නිකන් ළමයි බලන්න මේ මම හදපු එක තේරුණාද ඔයගලන්ට? Did you understand the way I did this question? 11th one. Yeah, you have 100 cubic centimeters of 0.25 m barium nitrate. So barium nitrate, this is the chemical formula. And then you have another 200 cubic centimeters of 0.1 m concentration of sodium nitrate, NaNO3. You need to figure out the chemical formula of them. Okay, and then they're asking what is the concentration if you mix these two solutions. If you mix them, you will get a 300 cubic centimeter solution. They're asking what is the nitrate concentration of this one. Concentration, you can put a symbol square bracket. We'll be discussing more about these things later. Okay, so they're asking the concentration of nitrate. Okay, so here's the volume, here's the concentration. So M, here this M I have explained. This M stands for moles per decimeter cube. Okay, when you are writing reviews, you are okay to write this one. But in the exam, don't write capital M. Okay? In my board, it is a small thing now, that's why I am writing this. So it's better to write moles per decimeter cube. Okay, so how do we find the moles? So moles of barium nitrate, BaNO3 twice. Moles of barium nitrate. You can multiply the concentration and volume. Okay, so 0.25 moles per decimeter cube is the concentration. The volume should be, you can't put 100 because then it is 100 cubic centimeters. So you have to convert 100 cubic centimeters into decimeter cube. So what is the decimeter cube value? How do we convert centimeter cube into decimeter cube? In your earlier classes we discussed. Okay, I'm going to a little bit discuss this part again in this week also. You have to divide by 1000, just like you are converting milliliters into liters, because cubic centimeters are milliliters, no? Decimeters are liters. So how do we convert milliliters into liters in earlier classes? By dividing by 1000. Understood? So like that here, it is 0.1, 100 division 1000 is 0.1 decimeter cube. Okay, don't worry about the simplification. So then මේ කරපු simplification එම අමාරුයි නම් ඔයගලන්ට give up කරන්න එපා ළමයි. හිමීට ටික කරන්න. දැන් ඔයගොල්ලෝ හිතන්න. ඇයි මම 100 එක 1000 කින් divide කළේ 0.1 දැම්මේ කියලා. මේ පොඩි maths කැලි තේරෙන්නේ නැත්නම් අහන්න ගන්න ඕනේ. ක්ලාස් එකේ ඕන කෙනෙක් ඕන්ලා අහන්න මම කියලා දෙනවා. Okay, anyone can ask any question. Okay, so I'm there to explain that one. So don't hesitate only. So what is the answer then? 0.025 moles. This is the moles of, you can now see this decimeter cube to per decimeter cube units are cancelled. That's the number of moles of barium nitrate. Alright. Now this reaction, barium nitrate in water, it is broken into two ions. Actually these reactions I should be giving you. Okay, මේවා හරිනම් පුතේ ඔයාලට දෙන්න ඕනේ. තාම ඔයගොල්ලෝ මේ reactions ලියන්න දන්නේ නැහනේ. But still you can see From 1 mole of this compound, you will get 2 moles of this one, no? Isn't it? So from 0.025 moles of this whole compound, you will be getting 2 times like that. That means 0.025 into 2, 0.05 moles. Okay. So from nitrate, here you are having nitrate 0.05. Okay, did you understand that one? Then you can work out in the same way, find the moles of sodium nitrate, concentration into volume 0.1 mole per decimeter cube. Volume you can divide by 1000, it is 0.2 decimeter cube. You will be having 0.02 moles. 0.02 moles. Okay, so then that compound, sodium nitrate, if you break this one, you will have sodium plus and NO3 minus. So one of this compound, 0.02 of this compound will give you 0.02 moles of nitrate. Okay, so here from nitrate you will be having 0.02. Is that clear? So if you mix them together, the total nitrate you will be having, 0.05 plus 0.02, 0.07 moles. Okay, 0.07 moles. That one is there in 300 cubic centimeters now. So what is the nitrate concentration? Nitrate concentration is, you have to divide moles by volume. Moles is 0.07, volume is 300. That 300 means, if you put it into decimeter cube, 0.3 decimeter cube. Okay, here you will have the answer. Here you will have the answer. Okay, just check the answer one more time. It is not that divisible. Okay, it's 0.7 division 3, 0.33 moles per decimeter cube. Is there such answer? Check answers. Yeah, there is answer. 11 answer 3. RS. Okay, look at the working line. Make a ටිකක් විතර අමාරු question එකක්. මේක දැන් මට පේන මේ chemical calculation set එකම පොඩ්ඩක් විතර level up වෙලා තියෙන්නේ. They are little bit difficult than the questions we did last time. But lamai, this is the maximum level they ask in the A-level exam. From these topics we discussing. Try to understand. අපි පොඩක් තව simple level එකේ question ටිකක් කරමු. කළා මේවා ආයෙත් පාරක් try කරමු. Okay, it's okay to තේරෙනවා නම් ගොඩක් හොඳයි. But if you are still fine, you can do them. Don't worry. 0.033 moles per decimeter cube. 0.233 moles per decimeter cube. 0.233. Okay, so what did we do? We found the moles of barium nitrate, and we found how many nitrates are there. Then we found the moles of sodium nitrate, and we found how many nitrates are there. Then we got the total moles of nitrate by adding them, and then we divided by the volume to find the concentration. That's what we did. You can put it in words also. Okay, we will try more questions like this. But anyway, keep the explanation with you in the written way. Okay, the main question එකට written answer එක ආයික හදන එකයි ඔයා ලියලා තියාගන්න ඕනේ පුතේ. හරි? එතකොට in the class I can explain this one to you one more time. තේරුණා නේද? හරියට හොඳ questions 10ක් 15ක් හදන්න. එතකොට ඒ ටිකෙන් ඔයාට මේක ආයෙ ආයෙ revise කරලා හොඳට තේරුම් ගන්න පුළුවන්. Okay? Right. We'll go to the last question. You are having the recording of this one also on it. Okay, so when it is needed, you always come and you can watch this one again. So last week I sent a message to the 2026 batch. I included the all paper class recordings I did for them, 1 to 34. So there are 34 videos, okay, from beginning. If anyone want to revise the whole syllabus once again, they have the chance. Okay, so the last one, let's see. The 12th one is telling, this one is not that difficult, lamai. Balanna. Ca3PO4 twice. Right? And you are having 4H3PO4. And next one, 3 Ca3, sorry, C. Yeah, I might want to write this one. Sorry. Wait. What is the first compound? The reaction is balanced, Lamai. What do you think? How do you check whether it is balanced or not? You can check the atoms in both sides. Right, now look at this one. Now it is given 100 grams of this compound. Okay, Lamai, 100 grams of this compound. So, how do we convert the mass into moles? So, we learned about that. We can find the moles by dividing this mass by the molar mass of this compound. So, what is the molar mass of this CaH2PO4 thrice? It's a big compound. So, we have to add them obviously. 40 plus, there are Lamai 6 hydrogens. Can you see? H2, the bracket 3 is also there. So 1 into 6, 31 into 3, and oxygen 16 into 4 into 3, 12. 16 into 12. Okay. So if you add them up, you can get the molar mass of this one. So what is the molar mass of this? Did anyone found that one? We can save some time. What is the molar mass of this compound? CaH2PO4 thrice. What is the molar mass of this one? 40 plus 6, 31 into 3 means 93. And 16 into 12, 160, 32, 192. And 92. So if you add them, 9, 11, 1, 10, 14, 23, 2, 331. Yes. 331. Is this 2? Did I make a mistake? H. Wait. Yes, it is 2, no? Sorry. Yeah, it should be like 2. H2PO4 twice. Then all these things should be changed, no? This should be like 4 and 2 and 8. Okay, so then here it is 4. Then what is the value? 31 into 2, 62. 16 times 8. 128. 234. 234, is that correct? 234 grams per mole. Now you can see, it is not obviously divisible. So let's not try to divide that also. You remember the last time we did some questions in our last paper class? Okay, so instead of dividing the answers fully, I showed you some short methods to do the MCQs. So don't divide this one, okay? Just keep it in this way. Now the thing is, you will be getting this number of moles. Now, let me show you one very important thing. Here, what are the numbers these numbers put in front of these chemical compounds? Here you don't have any number. That means you have number 1. So that means 1:4:3. These are called as the stoichiometry ratio. Okay, so we have to discuss actually in these our classes. So anyway, that means 3 of this one needs 1 of this. That's the idea. So if you are having 100/234 of this compound, That means we need 1/3 of that value. Okay, so when you are converting this one, moles, okay, let's say here you are having 6 of them, then you need 2, then you need 8 and 2, like that. Okay, so if you are having 100 over 234, that means you need to divide that one by 3. That means 100 over 234 into 3 here. Okay, that is the number of moles. So that called as the converting the moles. We will be doing some simple questions this week, but let's keep this one as the exam level. Okay, then you can come back again later and check this question through the video. Okay, so in our theory classes we will be learning from basics to this level. Okay, so that is the moles of calcium phosphate. So then what should we do? We need to convert that into mass because they are asking the mass. So we can get the mass by multiplying moles into molar mass. You are using this same formula. You subject the mass. Mass is equal to moles into molar mass. N into capital N. Okay, so that formula. So what is the mass here? Moles here, sorry. Moles are 100 over 234 into 3. That is the number of moles. And you are multiplying that one by the molar mass, calcium phosphate. What is the calcium phosphate molar mass? There are 3 calcium. So 40 into 3, 120. 2 phosphorus, 30, 31 into 2, 62. 8 oxygen again, 16 into 8, 16 into 8, 128. Okay, so it is 10, 1, 310. So you have to multiply this one by 300. Is that clear? So then this is your answer. This is your answer. So without exactly simplifying this, by rounding it off, we can go to the answers. So these are the answers. They have given 22, 44, 75, 132, 226. Yeah, those are the answers. So by rounding it off, we can go to these answers. Okay, let's give it a try. Is there any simplification error up to here? No? Okay, right. Now, what is after this? What is after this? Yeah, 234, 310. So you can cut this, no? Let's say I'm going to write this one on this side. We have to select suitable numbers, no? We can't just write some numbers and divide. Okay, 100 into 300, 3. Here let's write 250 wage. Okay, and here you can say it is 100. Cut it and say, and for you can cut another 0 here. Then here you have 4. Answer should be something above 40. Answer should be, so here the answer you are getting is 40, no? But that answer, actual answer should be greater than 40. Greater than, why did I say greater than 40? Because this number is a small value, no? So when this number is small, still I rounded it off to 250. That means I rounded it off to bigger number. That's why. So therefore, if the actual number should be less than this, then your answer should be go up a little bit. Okay. So answer should be some number greater than 44. So without simplifying, the closest answer you are having is 44. You can guess that and go. Understood that, Raman? That is how you are getting the answer without simplifying, because it is not divisible by 234. Okay, if you were going to simplify this one, you might need a calculator. Okay, sometimes there may be some factor that you can able to cut this one, but it is not clearly visible here. No? Okay, so this is the answer for the method for the last question. Okay, now I have to tell you something, Lamai. These chemical calculations are somewhat exam level questions. Okay, so these questions are you have to practice somewhat more in order to get into the properly do this fast and everything. So some of you might not get this one 100%, but still wait. You can try these questions with me. When we are doing more questions, these things will be get better. So the purpose of doing online class is giving you a recording and giving you a revision of the topics. No. So now we did a very good 4 questions. Okay. So you just started the subject, but now you are trying to do some exam level questions here today. Okay. So these 4 questions are really good questions. At least if you understood even one question, that is very good. Okay. So other 3 questions, maybe the other questions that you didn't get properly, you can still understand later with the theories we are practicing. So this week I am focusing more on chemical calculation in your theory classes. So I told you that we are going to start stoichiometry this week. So we'll be starting the class from that one, and we will do some questions and get into this theory properly. You can see here I use this ratio 1, 4, 3, and I did something like this. No, there is a name for this also. We'll be discussing more about questions like this, and let's practice this more. At the end of the class, let's do this one again. Okay, right. Okay, so this is the question I told you that we will be doing at the end. So having a theory regarding stoichiometry. So what did we do here? What is the summary of this last question? We found the moles of one compound. The mass is given. We found the moles of that compound. And from that moles, we got the moles of another compound in the balance equation. There we use the stoichiometry ratio 3:1. That's why we divided this one by 3 here. And then we found the mass of that relevant compound again. Okay, so it's sort of we climb up and we cross the bridge and then we climb down. Okay, so something like that. Okay, so thank you all for staying, Lamai. So this is it for today. I'll be adding a recording of this also. I had to do some editing and all to short the time, and I'll add this recording to our group. So you can access that one from there, and try to nice write review and bring it to your theory classes. For the tomorrow classes students, I think you don't have much time to do this one. Some of you are participating for the morning class also. So for them, but they have to finish the last week recording and bring it. This recording, it is okay to if you already write something in the book, please bring it. But if you are waiting to write a proper review, it's okay. You can bring it in the next week. Okay. For the other classes, Panadura and Dematagoda classes, you can you have to write the review and bring it to the class. Okay. So then again, of course, if you are having any doubts regarding the questions we did today, I know some of you might have the these 4 MCQ problems. You always can ask the how to do the things. Okay. So I'm ready to explain any point. Okay. Right. So I'm telling that one again and again because I know these questions are a little bit tough, but this is the level you have to practice. Okay. It is bitter at the beginning, but it's get better at the end. Okay. Right. So good night, everyone. So study well. We'll be seeing you in our theory classes and next week paper class. Okay. So goodbye. Good night, everyone.